Hey, this is 62 energy. And the question is, if you're driving at 90 kilometers per hour and your car just slows to 70 kilometers per hour over about, I think it was, is it 6 seconds it says? 6 seconds. In 6 seconds. And this is in neutral, which means there's no power from the engine. So it's just, if the car is like this, you're moving, but there's only friction force. There's no applied force. So the net force is the friction force, okay? So you say to yourself, how much work is friction doing in this time? Well, the very first thing you need to do is convert these. So 90 is 25, we did it before. And 70 is 19.4. Here's a second, so we need to know those. And we're gonna say, okay, the work done is gonna be the change in EK, change in kinetic energy. So that's gonna be the final minus the initial kinetic energy, which is gonna be half mvf squared minus half mvi squared. Okay. And we know, did they tell us the mass of the car? Oh, we do know the mass of the car. It's 1,000. Okay, great. So this is half m times vf squared minus vi squared. I just kind of lazy, so this is going to be 500. And that's going to be, the final is 19.4 squared minus 25 squared. Okay, so that 94 squared minus 25 squared. So that times 500. So our change in kinetic energy is, oh my, 1, 2, 3, 4, 5, 6. Sign of the apocalypse or something. But I didn't, did I do that? I'd have to times, no, I did times by 500. Wow. It's that many joules. That's the change. Now that is the delta energy. And so even though it's the loss in kinetic energy, it's also the work done by friction. Okay, so what does that tell us? What that tells us is that friction will take this much energy when it's kind of around 80 kilometers an hour, right? It's close to 80. It'll take that much energy in 6 seconds. So let's divide this by 6 seconds. And we're gonna get about 20,576 watts. That's a joule per second, so a watt, okay? So friction will eat that amount of power every second. It's gonna burn this many watts when you're driving around this speed. This is a kind of a nuanced question because you have to understand that friction will change with velocity. We don't talk about that a lot in high school, but it does. And they give you the 90 and the 70, and then they ask you about 80. Because if it's losing that much going from 90 to 70, it's probably on average this much power loss by friction. So this is the amount of power you're gonna need to drive at 80, because this is the power that friction will pull out of the car. And so you have to supply that much power just to replace the heat that's being generated as the car rolls. They probably rounded that because we don't have that many sig figs.